Okay, hello everyone. We'll be discussing about web services today. Okay, web services is quite well-known term in today's world. Like, people are. So, before going to deep, I will give you some introduction of what web service is. So, we'll go through history and then we'll come back to the web service. So, if we see the history when the web started, worldwide web started. We used to have static pages that was only based on HTML, like pure HTML, and some hyperlinks. So you used to navigate from one page to the other. That was all. And slowly, it started getting complex, and we had more dynamic pages. But people started using many programming languages to build applications. And the problem which they were facing is how to communicate between two different heterogeneous applications. Given I have my application and my application want to communicate with a different application, so how would that communication happen? So to solve that problem, web services came into existence. See, there are two applications, and these two applications are on two different networks. And now these two applications wants to communicate with each other. And application one might be in completely different language, and application two might be in completely different language. So in order for this communication to happen, web services was developed. We already had RMI. Yes. So, talking about those communications, we already had it. It's not a new. We already had RMI, Corba, and those things. But problem with them was they were able to communicate the same language. The server, or if application in network one is written in Java and application in network two is also written in Java, then only that communication was possible. But if one is written in C++ and other is written in Java, then communication won't happen. So the main objective to solve this problem was to have a neutral language which both can understand. Even Java can understand and C++ can understand. So they came up with this XML. So Java will produce a XML and C++ will also produce XML, and through that neutral language they can communicate with each other. XML is nothing but a hello page. So now getting to web service. What is a web service? Okay. So web service is nothing but any service which is exposed through web is known as web service. Now even the websites are exposed through web. So can we call that as a web service? We cannot call web service, website as a web service, because web service mainly deals with machine to machine communication according to W3C. So a website is mainly meant for human interacting with the servers. So we have website. So that is why website cannot be completely considered as a web service. In web service, what happened is a particular machine will communicate with the other machine. So that is over a network, and that is what web service is. So we'll get into more detail about web service through service. Service can be anything. You want some information, or you want to process something. So can be called service.
There's website. You mean the bank?
No, website, yes. So yeah, here comes the need for web service. Why the web service is possible? This is what we discussed earlier. There are few points which are very important in this slide. Interoperability. So basically, I don't want I want two heterogeneous applications to communicate with, and that is possible through XML or JSON. JSON is a lightweight version and lot more efficient compared to XML. Okay. So here I have okay. So here is a simple REST application which like day-to-day life. We have many airline companies and we want to book a ticket from place A to B. So what will happen is um, I will enter two destinations A and B, and my application will communicate with the APIs, REST APIs exposed by the airline companies through all over the airline companies like Jet Airways, Air India, Go Air, and it will consume their APIs and the prices offered by them, and then we'll be able to see all the prices which are available on that particular date. So this is how a simple REST application can be used. So here a machine is interacting with all other servers of the airline company. Okay. Now here comes an important discussion, which is SOAP and REST. Yeah, there are other ways, but that is also can generate that, right, but that is not more used as compared to soap and rest. Okay. Even I don't have so much understanding of Ajax, but I think that it is possible to obtain this. But now it's like soap and rest is more used, and today's I think rest is the Mhm.
That's probably you can't.
I'm not saying that it's complex, but and that is why soap and rest are used because their main objective is web service.
That's why.
No, no. Effort is like you have to have provide more. You see, rest is nothing but Jersey is nothing but a Java. So that way, even
From there, you find the resources on server side. As I said,
yeah. So these are two mainly used terms in web services. So it's very important to understand the difference between SOAP and REST. Basically, we shouldn't compare SOAP and REST. Each has their own pros and cons. But in simple understanding, there is an analogy to understand SOAP and REST. SOAP is said to be can be compared as, if you compare the letters, SOAP can be considered as envelope.
we use within web pages, right?
Huh.
Okay.
So okay. So in SOAP is like a letter which is covered and like is placed in an envelope. But a REST is simple postcard which can be read by anyone. This is a basic analogy. What SOAP does is it uses encapsulation on top of the like encapsulate its data. But whereas REST doesn't do that, but it doesn't mean that REST is not secure. It uses HTTPS at the end to secure its data. So SOAP is a protocol and REST is an architecture. If you would try to understand what is the difference, protocol is like a very broad term and it has like lots of uh, rules and regulations one follow, and that's why SOAP is like more standard compared to REST, and that is why these days everyone have their own way of doing REST, which is uh, appropriate. And yeah, so and moreover, REST like it mainly uses XML, whereas in REST you can use any like XML, JSON, and the reason REST is like more efficient is like you can use JSON and it's very lightweight and very easy to use. So REST, the efficiency and performance of REST is slowly like it improves to a great extent.
Another transformation binary.
That happens at the end. That is the end thing. Okay, that is the end thing. But the main objective here is like producing file which a program can read. Okay. So which is a neutral file program can read. So here this JSON and XML comes. Then one more thing, a simple way to understand SOAP and REST is REST exposes everything, all the resources through their URI. You can obtain each and every resource through a URI. Whereas in SOAP, it doesn't happen that way. In SOAP, you have a single endpoint, and through single endpoint, it will have list of instructions, operation which is given through wizard, and you need to perform those operations and actions which are listed there in order to obtain what you achieve. So that is little tedious in scope, and that is first point of risk. We'll discuss why. Uh, That full stop defines that one need to be very efficient on doing things. I should have ignored that last full stop as well.
Right.
That would have saved my time. Second,
Nobody.
yeah, there is logical reason. The logical reason is that we'll discuss on next slide. Now coming back to advantages of rest. So why rest becomes so popular that today about 70% of the public API uses rest. Why? The reason is very simple. Rest is not easier to understand and compared to so, but it depends on the situation. But in general view, it's a lot easier and very simple to understand. And moreover, you have this JSON. JSON actually improves the performance, which I already told, and it's less complex. And moreover, you don't need expensive tools for things like digital understanding digital and performing some hyper. So yeah, these are the few points uh, rest gain popularity. No, no, we use JSON. That is why rest is fast compared to.
How
See, if you compare XML and JSON, uh, JSON has XML has lots of overhead compared to JSON.
far
There are many tags which you don't need. You simply put a key value there, which if you see we'll see a JSON and XML file. Yeah, that is what overhead is. Yeah. Okay. This is very interesting topic. We already we need to figure out, like, first of all, what is a rest? Rest is, if you see the definition of rest, is a state transfer. Okay. So we need to understand what a state is. Okay. So basically, we need to understand what are types of state, and then there are two types of state. One is application state, and second is resource state. So application state is nothing but the state of your application. For an example, if I do a get request to the server or a post request to the server, okay, the server may not remember what was the previous request you made. So this is what a resource state is, the state of your resource which you are exposing. So which you are exposing to a URI. That is what a resource state is. So here in REST, if you see representational state transfer, so actually it's a transfer of resource state. Okay? Transfer of resource state, some representation. Representation is what XML or JSON, that thing. And it is stateless in respect of application state. Now comes the very important topic of REST, the architectural principles of REST. So we need to understand these five principles in order to build a good RESTful application. Okay. So now I'll go through one by one, but I will give you, I'll navigate through an article which will give you a real use case scenario where we'll see what is.
What if someone does not follow these
It is not
constraints?
necessary to follow. It's not
Yeah, that's why
necessary to, but everyone has their own way. But if you, if there is a way to see how restful your service is. We'll get that on the next slide. They can, they can, they can. See, if you are doing that according to your business needs and your business is working fine, then no issue. Like Netflix has done that. Netflix has totally deviated from the rest services, and they have now defined it, and they have their own architecture of it. So that is okay. If your business need is being fulfilled, no issue. But exactly, that is what I do. According to that is what I'm doing. According to if you are not following and then getting met, it's okay. But it is good practice to follow this thing because I tested. It's not only usability. See, main thing is if you don't have a particular standard, it will be difficult for the second person to understand what. Yeah, it will be difficult for the second person to understand what you have developed. Okay. So coming back to the architectural principles. First thing is addressable resource. Okay. Your resource should be exposed through URI. You should be using uh, URI to expose your resource. Okay. There are three things. One is URI, second is URL, then you have URL. Okay. URL, first we'll discuss URL and URL. There are two things. First is location, second is if you are trying to access anything through its name. If you see a book, it has ISBN number. So that is URL. Okay. If you are trying to access anything through the name, it's URL. If you are trying to access to its location, then it's a URL. But in URI, it's both. Both URL or URN can be called as a URL. Okay. Yeah. And URI is like more. It's like if I talk in terms of analysis. Okay. So if you are telling where do I live, I will say I live in Panathur. But if you are telling I live in Panathur and if you give a way to reach there, then that is URI. Okay. So basically URI have URL can be URL it is URL, no doubt in that. But if it is a URI, yeah, see, it's nothing but there will be URI, there will be URI, I mean URL, and URI will be on top of this both. So anything which is URI or URI is URI. Okay. But yes, there is something. If I say if I use fragment, okay, if I use fragment, then it is not necessary to be URL, okay, but it is a URL. If I use a fragment to reach somewhere, okay, then it is.
But the fragments are not used.
Fragments
are not used in REST or access resources. They are only used in web page. Here you have mentioned that fragment has.
Just an example.
Okay.
What a URI does, an example. So, and then coming back to second point, uniform constraint. Okay. So basically, uniform and constraint interface is like methods, basically HTTP methods. You need to have all the HTTP methods which is already there. And these days, people are using patch a lot. Which is not a standard HTTP method, but people are using. So they are deviating from the rest. But exactly, that is what thing is like. People are using. I'm telling that people are. It is not that people are following. People are using. So patches are according. Yeah, people have their own way of doing it. Okay, their own way. People are doing that. Okay, okay, we'll.
What does
Yeah, I will tell. Yeah, I will tell about this. First thing, why is uniform and constant interface? Like familiarity, like people are familiar with these things and it understand interoperability, like to have a common thing and scalability. Okay, when coming to scalability, see, if you have a well-known methods compared to the unknown methods, then you can use it anywhere, anytime, with the consideration that nothing will break. Okay, but if you are using a non-standard method, there are chances of that it might break, be it server side, be it the client side, kind of. Okay. You can like have it.
resiliency, not scalability? Uh,
Actually, it's like you can expand things and you are sure that nothing is gonna break down. Okay, so that is what scalability is. Like you can expand any time, and you're sure that nothing is going to. If you are using a uniform and constant, but if you are not using that, there might be chances of things breaking. Okay. Now coming to representation oriented, it's the same thing that even your services and services should be everything should be exposed to URI. Content negotiation will have a different slide and we go through that content. And the fourth point is communicate statelessly. I already told that stateless will communicate. And the fifth is the most important part, hypermedia as the engine of application state. See, hypermedia, okay, we are using URI to uh, URI to expose our resources. But when you are sending a response, when you are sending a response, it should have all the possible URIs that will ease the access of resources, like next and previous. Okay, so that way the customer or client can easily navigate through the end up till the end where it wants. Oh, an example can be taken as like when you are shopping in Amazon, you start with a single website, okay, and then you slowly you add to cart, you go to payment, account, but you start with a single website URL, single URL, and then up to end you don't need any other thing. So it is something similar to that. Okay. Okay, now Jersey. Jersey is nothing but implementation of JAX RS, which is available in J2EE, and yeah, it implements the JAX RS, and we have annotations and interfaces which if you want detail, you can refer this JSR 3 comma. Now, Richardson maturity model. Okay, the thing which we had, the discussion which we had, where you were telling about the how deviated your application is. In order to find out, we can use Richardson maturity model. Okay, we'll start with level 0. That is, if your application is at level 0, it is not a RESTful API. Okay, so what is a level 0? If you have a single endpoint, okay, if you have a single endpoint and you need to do all the operations, you need to obtain all the services through that single endpoint, then it is at level 0, which is what SOAP is. Okay, so SOAP cannot be called a RESTful service because it uses a single endpoint. Now coming to level 1. Level 1 should have a single URI, at least a single URI, and you should be able to navigate to wherever you want uh, throughout your resources. Okay? And level 2, if you are using all the HTTP words, methods, everything, then you are at level 2. And here comes the level 3, heteros. It is not only about exposing a URL, also about providing all the necessary, like next and previous. You may not give that next and previous and still be at level 1 or level 2. But if you give next and previous link to next and previous resources, you get level 3. I will show you a real world example. Okay, I'll browse to what the fuck is this? Okay, I'm showing an article by Martin Fowler, and we'll be understanding it through a real world case. How is your application, up to what level is your API RESTful? So here in this example, if you see, okay, here in this example, if you see here, a request is being made, okay, to a single endpoint, okay, single endpoint, and then you get a response, someone trying to book an appointment, and then you get a response that says, hey, see, here are the available slots, and whatever slot you want to book. So using the same endpoint, yeah, you will make an appointment request, and then you'll get. But how on the server side came to know that this is the appointment request? You need to get uh, something. This is something which is being done in scope. So you need to have something like crystal, where you'll understand what action to be performed, how. Okay. Now coming to the level 1. Okay. So in level 1, you see that we need a URI, which is here. You are trying to get the available appointment on this, and then you get a response giving you the available slots. Okay, and then you try to go to a particular slot. See, this is a different URI, not the same URI, different URI. Okay, and then you make an appointment. Okay, and then you get a response that your appointment is confirmed. Now coming to level 2. In level 1, you might not be using all the HTTP words or all the HTTP methods, But here you will be using, if you are using all the HTTP methods, then it's called level 2. Now coming to the level 3. Okay, so in level 3, if you see the response here, it has not only given you the required detail, but also the uh, other useful URIs that you can use, and it makes it easy to navigate. And if you are achieving this, then you are at 3. So
What is REL attribute? Uh,
see, this is a tag, this is nothing but a tag that is helpful in creating efficient URI. Okay. Now coming back to our slide, Richardson message model we have done. Okay. Now this URI design. Okay. Many of people design their own URI, and they consider it to be a perfect URI, but there is a way to design a URI. First thing is like it should be intuitive. Intuitive is like easy to understand, but this topic is a debatable. How I will come here cover this point. But second, we'll come back to basically URIs. The discussion between whether it should be a noun or it should be a verb. Basically, it deals with the collection of resources. If I say messages, okay. So messages is the collection of all the messages. So basically, it should be a noun. But some people even expose something as get messages. So that is not a get messages. It's not a proper way of defining it. Now coming back to plural versus singular, it should be dependent on.
so if there is a system which cannot be made with standard methods, that case you have to either consider that operation as part of URI or as part of a
Your is that you don't have.
for example, say for example, I want to go operation is standard words. For that, either you need to put it
Log to want to log the response on the server unit. So you want it to be completely logged so that no other client. Then how what you want to ask that?
how would you design that API for particular?
That is the customized part. That is the customized part of your operation, not the URL. Okay, you are trying to
But
operate.
that's what I am asking. How would you
You are trying to log what?
the resource?
What is the
There is a message.
okay? So when you are designing a message, it should be a noun, okay?
Yeah.
And then you are trying to perform some operation. Which operation you can customize? So it has nothing to do with the name of the UI.
It has
How will you? Um, what do you expect from a UI?
not only the URI, so I mean, a REST request to URI and then don't payload.
What do you expect from the UI?
I mean, either we can use the either we can define that operation as a resource and consider that as part of the URI.
You are operate. You are trying to perform some operation on a resource. So resource has nothing to do with the UI. It has to do
What
with
I
the
mean to say is
operation.
how would that API look like? I mean, for
It
local
will-
resource?
it will look like a simple API. You can, if I say messages, you can get a message, okay? You can update a message, but it doesn't mean that your message API will change all the time you operate something. If I say get, Okay, so it doesn't mean that for getting a message I will have a different URI. No. You are trying to perform some operation on this URI. So your operations can be anything.
But on a URI, I want to perform a log operation. How would I do it?
You have some customized operation perform on that URI.
How would I mean how will the client request? I don't
First of all, if you are customizing anything, your client should be familiar with that customized operation. Okay. So in that way, your client, if your client is aware of that operation and you have a URI, your client can perform it. Okay. Now coming back to opacity. This is a very good discussion which tells that whether your URI should be easy and simple to understand or it should be complex to understand. If you see the first example, it says customer slash 123 slash. The client easily understand that there are other customers just like 1234. There are other customers like 4568. Okay, and he may start hacking and look workarounds to get things done. Okay. But in case you later decide to change your structure of URI, let's say you decide to put orders on first place and 1234 on second place, then the client code might break. So it's not like always a best practice, but it is considered as a level 3. If you introduced opacity, it is considered as a level. If you don't consider the opacity, it is the level 1 and level 2. In level 3, what they do is, you see the second example. Second example is like uh, it won't be as simple as customer slash 123. Okay? It will have complex URI, and of course, the customer will have all the useful URIs to navigate from one. And there is this point where you shouldn't use underscore and file extension like this dot JSON or something, but really forward space. And now here comes content negotiation. Okay, so a client may not understand everything. Like like a client may understand JSON or XML or both or anything. And so client, what it will do is it uses header, which is accept header. I will show you one demo. Okay, here the accept header, and it will have JSON. I'm trying to get a uh, JSON response, and let's see if my server is able to return that. You see 200 okay response, you get this. Now what I do is I change this as XML. Okay, and now I try to the response. See, it's not acceptable. Okay, because the server doesn't know how to convert it to XML. So you can change that. See here I have written it as JSON. So here if you change it to XML, the client can understand. So these things you need consideration. Okay. Now calls, pagination and filtering. Here also we have a term like scalability. Okay. So here what scalability is like, if a server asks for messages, there will be tons of messages, like hundreds and thousands of messages. But if I return all the messages at once, it will be overload for the server and then difficult for client to understand. So we'll have pages, we'll have limits up to which we'll return the messages, like 10 messages at once, 50 messages at once. And here in scalability, you can have like tons of messages and you can, but you don't have any problem because you are anyhow return 10 or 20 messages. Here comes another topic, that is handling. It's always good practice to like deal with all the possible exceptions that can happen, and not let the client try to debug what might have happened. There should be a proper messages for the client or even us to understand what might have happened. But if you see, HTTP has around 70 standard code. But if you try to communicate with Google, you see that they return about 9 status codes, because the limited number of status codes you have, the easier it happens to understand, because no one will 70 status codes. And then coming to the last point is like, yeah, you should have proper status code, like, and then message for developer, message for end user, and your own internal error code to figure out what might have happened, and links where any questions, sir? Okay.